Salvator with NVIDIA. I am Director of Accelerated Computing Products, and I'm being joined by Uttara Kumar, who's a Senior Product Marketing Manager, as well as with Matt from Microsoft. And we will be taking you through some content about generative AI and what it takes to deploy that in the cloud. So, generative AI has obviously been generating a huge amount of buzz and interest for just a whole variety of reasons, not the least of which, of course, is its ability to generate so many different things, whether that's generating actual text, like with ChatGPT, generating just amazing images, even generating code based on sort of plain language description, doing more intricate and more accurate translation, or even doing things like molecular simulation for life sciences. We're really just beginning to understand all the possible applications of generative AI. And so while AI and really the deep learning sort of revolution has been going on for over a decade, generative AI and large language models have now just sort of taken us to kind of that stair step next level of possible applications and things that it can be used for. In addition, the other kind of exciting aspect of this has been what I kind of call the element of play, in particular with things like the image generation we've seen, generating images from text. You can even now generate video and even 3D rendered images from text. And what that brings is almost this element of play to AI that allows people to kind of play and interact with AI. And to quote our CEO, Jensen Huang, he basically says, generative AI has turned everyone into a programmer, right? And so we're really at this really interesting moment in the history of AI in terms of the potential impacts it can have across a whole variety of usages and across almost every industry. Now, enabling generative AI is not trivial, right? I mean, there's just so many things that need to go into this. The first thing, of course, is data. Data is really the life's blood of really any AI, because ultimately the data is what is used to train the network, from which you can then begin to make predictions or generate content, right? So having, well understood data, or just, data that has been sourced in a way that is legitimate, that won't sort of get you in any kind of legal hot water, super important. And then the ability to take that data and train, which is also can be a very, very compute intensive task. And we'll talk more about ways to accelerate that task, both in terms of both compute, as well as doing what's called fine tuning training. And we'll talk more about that in a few minutes. And then, of course, adapting it to different usages, right? And we sort of just list out a couple of potential usages there you see on the right-hand side of the slide. So one of the other pieces, of course, and we've been going along here, we actually put this chart together to kind of help illustrate the point that large language models and generative AI models have been rapidly driving the expansion of the size of these models. As big as now, one of the models that Microsoft has made available, which is called Megatron Turing, NLG 530B, is 500 billion parameters, right? Just a massive model that takes a huge amount of compute to be able to train effectively, right? So generative AI and large language models, very exciting, but also present some real challenges around getting them trained and deployed. A couple of other observations I have on the left here. First of all, these models, as I say, continue to drive aggressive growth. The other aspect of these things is we normally think about the high performance requirements as being more of a function of training. But when you get to the inference side on a deployed application, most of the applications we're seeing for LLMs and Gen AI are being run in real time. So not only do you need to be able to get a computationally intensive answer, you need to do it in a pretty tight latency budget of, usually tens or maybe hundreds of milliseconds. So that puts an additional constraint in terms of the amount of performance you need to not only train these networks, but to deploy and run them 24/7, right? So while we think about, again, traditionally, training has been the place where we think about having the really big iron to do the computational work. It's important to understand that acceleration will be critical in delivering these applications in the deployed sort of, domain of services and products that will be out there running for your customers. So that poses, a number of challenges, right? We've talked about, mountains of training data, the amount of infrastructure needed to do the training of these networks, a lot of expertise as well. And we're going to talk a bit about some of the ways that we are going to make it easier to deliver Gen AI through a number of different services. And we'll talk more about that in just a few minutes. And of course, the algorithms continue to expand and get more complex to deliver better insight and better answers to these sort of novel types of data that we're using to train neural networks. So foundation models, the idea behind a foundation model is you basically take one of these big models that's big and hard to train, and you train it on a given set of data, right? At which point then customers and developers can then come in with their own set of data and do what's called fine tuning, which is to say, sort of add your data to that already pre-trained network to bring it further along to help it be able to be deployed for your specific application. There are some challenges around that in terms of, every time you train a model, you essentially are creating a snapshot in time, right? So sometimes it's not just about training, but retraining. And this is where fine tuning has a critical role to play, for the simple reason that you may need to go back, on the cadence can vary. We've seen some networks that are retrained as often as several times a day. It could be several months between training runs, possibly years. But at some point along the way, you will probably want to be retraining your models to maintain levels of accuracy and quality of user experience, right? There are issues around things like accuracy. We all know that while these models are very exciting and some of the things they're able to do, we know that as an example, large language models still have work to do around, accuracy and not basically generating either kind of false or potentially misleading information. And then there's also the matter of sort of bias in data sets. And so there's a number of challenges to be worked through there. And so these are all things that we continue to work on here at NVIDIA, and we work on in conjunction with Microsoft. So what does it take to deliver all this? Well, at the end of the day, what it takes is a full stack. We sometimes have a tendency to admire the hardware a bit too much, I guess I'll say. But what it really takes is a full stack platform to be able to deliver these services effectively, right? That includes, of course, the hardware, which is sort of the foundation of the house. But the real house is the platform software, the AI services that can be NVIDIA AI, NVIDIA AI Enterprise, and of course, services like Azure ML, which Matt will touch on in just a few minutes. All these things need to come together and work together, as well as services around things like foundational models, and we'll talk to you a bit more about that, to be able to make it easier for the larger developer community to take advantage of this technology and deploy models using it that can generate useful information and value for your organization. So kind of the engine at the heart of a lot of these platforms is our NVIDIA H100 Tensor Core GPU. This is our current flagship offering. What we're showing you there is a picture of what's called the SXM version of our GPU. This uses our NVLink fabric technology to allow inter-GPU communication at 900 gigabytes per second. It has a number of really interesting features, not the least of which is, of course, our Tensor Core technology, which is sort of purpose-built to really massively accelerate matrix multiplies, which is kind of live at the heart of most AI mathematical operations, right? But in addition, we've added a feature called Transformer Engine. So a lot of the breakthrough work with large language models has been happening on the transformer network architecture. And what the Transformer Engine does is during training runs, it will actually go through the network layer by layer by layer and evaluate, can I run this layer at an FP8 precision, which is also available in H100? If the answer comes, can I run that without basically adversely affecting accuracy? And if the answer is yes, that layer of operations will be run in FP8 precision. If it turns out that it's going to compromise accuracy, we use a higher precision, like what we call our mixed precision, which is math ops in FP16, and we accumulate the results in FP32. By doing that, we're able to deliver additional performance, and I'll show you a performance slide a little later on, that has really been kind of delivered breakthrough levels of performance for those networks that are based on the transformer architecture. And again, many of the LLMs today that are doing a wide variety of applications, not just language, by the way, are using that transformer model architecture. And with that, I'm now going to hand it over to Matt Vegas from Azure, who's going to talk to you about Azure's new instance based on the H100, which is the H100 V5. Matt, over to you.
Thanks, Dave. So my name is Matt Vegas. I'm the principal product manager for our ND series of virtual machines at Azure. And today we're talking about, how can you get started on generative inference? And to understand that, it's helpful to understand, what is it that we do at Azure that's kind of so special? And so this is how we build our ND H100 V5 VM series. This is Azure's most powerful and massively scalable supercomputer VM. At the heart of the system is the NVIDIA H100 Tensor Core GPU. It has 80 gigabytes memory, HBM3 memory, substantial performance improvements over last generation, PCIe Gen 5, and each system that we sell includes 8 GPUs per VM. Within each of these VMs, we use NVSwitch and NVLink 4.0 for the connection between the local 8 GPUs, which provides 3.6 terabytes per second of bisectional bandwidth within the node and 450 gigabytes of all reduced bandwidth. We then take that single server, or those single VMs, and scale it out using an NVIDIA Quantum 2 InfiniBand. And this is network. And this is one of those things that really makes us kind of unique in industry, where each one of our GPUs is connected with a 400 gigabit dedicated link that's feeding into a fat tree network topology that basically scales out our servers across just thousands and thousands of VMs. So this is how we train the models, but it's also how we run the generative inference applications that come from those models. So every generation, we build a new system that's specifically designed to basically get the most performance out of the latest generation NVIDIA GPU. I'm not going to go through every detail here, pretty much any of the details here, but if you just look at the platform overall, basically what we do is, we have to keep up with the GPU. And so we try to, from the ground up, we try to build, double every bandwidth, every speed, every capacity, nearly every spec in the system. We try to double it to keep up with the GPU. So how do you get started with generative inference at Microsoft? There's a lot of ways. And, a lot of the options here kind of depend on your specific use case and what level of complexity do you require for your use case. At the most basic level, you can always come to Azure and rent one of our GPU-based VMs. This will enable you to run models directly on, Azure's most powerful and massively scalable AI virtual machine. This is kind of what our, personal super users would do. You could also go to the Azure Machine Learning Service, right, which enables you to run your models on a fully managed cloud service. Basically makes it really easy to build, deploy, share your models. To even simplify things further, you can use our Azure OpenAI service. Basically, this will enable you to power your apps with large-scale AI models like GPT-4. Basic API access into these things to make it, really easy to program your applications. And then, hey, for just a day-to-day use of AI, this is also a productivity tool that we can all take advantage of. And, we've seen this over the last 6 months, and I think we'll see it into the future where Microsoft continues to add built-in AI into our tools and services. So you see this with, AI-powered search with Bing, with security Copilot, with Microsoft 365 Copilot, GitHub Copilot, Microsoft Teams Premium, Viva Sales, Microsoft Power BI. Basically, all of those applications now have some level of AI integrated into the products to make more productive in kind of your day-to-day operations. So that's kind of what we've done from the Microsoft side. I'm now going to hand it off to Uttara, who's going to talk about NVIDIA's enterprise software that's coming to Azure.
Thanks, Matt. So as Matt and Dave both spoke about, right, in addition to the computational power and scale that you require for generative AI applications, you also need optimized software, right? And the software needs to be able to support your end-to-end AI lifecycle, starting from preparing your data, building your models, training it, optimizing it for inference, and then finally deploying it within a service, right? So software is essentially what helps you leverage the full power of the underlying accelerated infrastructure and deliver the performance that it's capable of in your application. Which is why, in addition to working with Microsoft and making a broad range of GPU accelerated VMs available in Azure, like the NVIDIA H100 instances, we also work very closely to ensure that NVIDIA's entire AI software stack is made available broadly to Azure developers so that they can simplify this development and also get the best performance from their infrastructure. The NVIDIA AI Enterprise is our end-to-end cloud-native suite of AI and data analytics software, which is performance optimized, it's certified, and it's supported by NVIDIA for use in Azure. It includes over 100, pre-trained models, tools, and frameworks that will help you accelerate every step of your AI workflow. And you can access all of this optimized software today on the Azure Marketplace directly. And it's supported for use on all of NVIDIA's VMs in Azure, including the H100 GPUs that Matt just spoke about. This week, we also at Build, we also announced that we are integrating the NVIDIA AI Enterprise software into the Azure Machine Learning platform. So that really brings the best of both worlds together, which means within a single MLOps platform, which is Azure Machine Learning, you can access NVIDIA GPUs, you can access NVIDIA Optimized Enterprise software and support, and you have access to all of the end-to-end MLOps capabilities that Azure ML offers inherently. So to learn more about how you can access NVIDIA AI Enterprise software, whether it's on the marketplace or within Azure Machine Learning, we have two additional sessions at Build that you see linked here on the slides. And as a side, I also want to inform everyone that you have access to all the slides that we're presenting and the links under the resources section. So if you want access to all the links and the slides, you can have can download the slides from there. And then I'm going to move on to one more aspect of the H100 that we want to talk about. So we've spoken about compute, we've spoken about software. Now data, of course, is one of the most important ingredients for developing AI, right? And you need significant amounts of this data, whether you're building this model from scratch or you're trying to customize these models for your own use cases. If you're in a regulated industry, like, for example, healthcare or finance, this data that's required for both AI training or even for inference is sensitive. It could include personally identifiable information, patient health information, and other information that is subject to regulatory compliance, right? So this data needs to be protected at all stages, whether it's in storage, in transit, or even whether it's in compute, right? Now, today, there are a lot of techniques that are in place for protecting data in storage and transit, but there's a big gap in protecting data during compute. For example, when it's being processed by workloads like AI model training or inference, which leaves this data, exposed to internal and external attacks. In addition to data, there's also the AI model itself, right, which is very valuable intellectual property. And, it's the result of a lot of investments that you as a customer make in building, training, and optimizing these models. So you want to ensure that when these models are in use, they're protected as well. So confidential computing is basically a hardware-based security feature in the NVIDIA H100 GPU that addresses this challenge of protecting your sensitive data and protecting your AI models when they are in use. H100 is the first GPU that supports confidential computing, and it protects the entire workload that runs on the GPU with security that's guaranteed at the lowest level of the computing stack, which means at the GPU architecture level. You can be ensured that any unauthorized access, whether it's through the hypervisor, the host operating system, or even from anyone who has access to the actual physical hardware, it's prevented from, no one can, view or modify your data or the AI model when it is in use. Now, the NVIDIA H100 GPUs are going to come soon to the Azure Confidential Computing Service, and you can learn more about the feature and how to use it, when it becomes available in the blog that's linked on the slide. But then I'm going to hand it over to Dave for, a spin on the performance that you can get from these instances.
Okay, thank you, Uttara. One quick thing I should have mentioned at the top of the presentation, if you have questions, I know we're kind of tearing through content here pretty quickly, please ask them in the chat and we will work to answer those questions for you before we wrap our session. So with that, let's talk a minute about performance. Security, obviously a hugely important factor, as Uttara touched on, but it's also important to understand just how much performance is available through H100 and through the H100 instances that Azure is making available. These are the most recent results from both the training and inference side of MLPerf, which is an industry standard benchmark for AI that tests across a broad swath of usages here. And I guess the data point I want to point to you on the training side would be relating to BERT. And I point this one out for a couple of reasons. First of all, we had just a massive performance gain, gen on gen, of almost 7x, right, while training that network. And that was thanks in large part to our transformer engine technology that I talked about a few minutes ago, right? So just gen on gen, you're going to see H100 delivering just massive amounts of performance, and will be just a critical element to getting these large models trained, whether they're LLMs, Gen AI, what have you. But another data point I want to make you aware of is that even our A100, which has now been in market for a couple of years, and of course, Azure has a great A100-based instance as well. Over the course of the product lifecycle, we've managed to get about 2.5 times more performance out of that product from software optimizations. And so as you heard Uttara talking about the containers available from NVIDIA AI Enterprise, we are revving those containers on about a monthly basis, right? And then we republish them, and we're always looking to optimize performance, realize more performance from our hardware over time, as well as address any bugs that may happen to come up along the way. So, when you make an investment in the NVIDIA platform, and when you make that investment on the Azure platform using NVIDIA-based instances, you'll be getting more performance over time on the same hardware, right? So it's again, sort of additional sort of return on your investment. On the inference side, I would also point out that, if you look at, again, looking at BERT, large language model, you'll see that we got a little bit over 4x more performance there, gen on gen. And again, that is thanks to the ability on the inference side to be able to use the FP8 precision. And you'll notice that the accuracy level is 99.9%, extremely high level of accuracy, and yet we're able to achieve that level of accuracy using FP8 precision and also get a really nice performance bounce as well. So, we are on this cadence to continue to deliver, more performance, working with our cloud partners to make sure that AI on the NVIDIA platform running on Azure is absolutely as performant as it can be. Along those same lines, we've introduced, and this will be coming available on Azure as well, what's called the Nemo Framework, which is a large language model. And I alluded to this a little bit earlier, where you can basically come in with your own data set and be able to train on the Nemo Framework using sort of a very robust model that we have trained using an existing data set, right? You can then train with your own data on this model to make it more domain specific to your particular application and then deploy it. This will be becoming available. We have a session on this one as well. You see the session there across the bottom about how to build LLMs at scale. That session is happening, I believe it is today. Is that today? Today is May 23rd, right?
No, the session already took place, and so you
My
can view the
apologies. So you
recording.
can see it on demand. My apologies. Yeah. So, but the point is, there is a session on that. If you're interested, just check the course catalog for build, and you can check that session out. I should know what day it is. You think, right? And then on a related note, I talked about Nemo. There are two other foundational model services that we are making available that will be coming soon to Microsoft Azure. One is Picasso for text-to-image generation, and then BioNemo, which can be used for molecular simulation for drug discovery. The Picasso one I want to touch on for just a moment, because one of the things we've done there is we've partnered with both Adobe and Getty Images so that the source data being used to train models and to generate the images based on text input are coming from attributed and proper sources. So in other words, if you've seen some of the headlines about concerns about where is data coming from to train these generative AI models, and could it get you into some kind of legal hot water? For Picasso in particular, we wanted to just make you aware that again, we have worked with content owners and licensed content from them to be able to build and deploy this service, so that anything built upon it will also, be in the case where there are no legal concerns around copyright or ownership of IP. So just a couple of things to be aware of. And again, these will be coming to Azure later in the year. Okay, and so we are kind of coming to the end of it here. Let's see how we're doing on time. We got about 5 minutes or so. Just a couple of additional resources. There is a preview page for the Azure NVIDIA H100 V5 VMs that Matt talked about. We have a whole page on confidential computing with more information there if you want to learn more. More details about our NVIDIA AI Enterprise program, also now coming to Azure through the marketplace, our Nemo frameworks, and of course, our NVIDIA AI solutions on Microsoft Azure. So with that is our content. And we want to see if there are any questions in the chat and see if there are any questions we can answer for you before we wrap the session up.
So there were a few questions here. We've been replying live with links to more details. There were questions around what does the actual system look like. Let's see.
Amit is asking, will we share the presentation? Yeah, the presentation will be available from the resources
Yeah,
section
yeah.
of the Build conference website.
So in the session from where, on the window from where you joined the session, on the right, you should see a resources window. So on that, there is a link for session slides. You can get access to all the slides from that.
Okay. Any other questions we can answer in there, Matt?
There's also a question on how they can get documentation for getting started with NVIDIA AI Enterprise software. So I just posted a link to that.
Great. Okay.
We also posted a link to the Nemo session. You can find it from the slides as well that we linked.
Okay. Yeah, I'm seeing here. It looks like. Let's see. Rick, will there be low priority H100 SKUs available in Azure AML? I'm not sure what he means by low priority SKUs. I don't know if he means maybe spot reservations or what do they call them? Interruptible reservations or preemptible?
There will be spot.
Spot. Okay.
It's not available yet, but there will be.
Mm-hmm. So there's a question here from Jim about does this instance target training or inference or both? Since it's asking about the instance, I'll throw that one over to you, Matt.
So originally we built it for AI training, but in the last 6 months, generative inference has really taken off, and this is still the system that's required to run really large models.
Mm-hmm.
So the types of generative inference applications that are really interesting today, they still run on the systems that were designed for AI training, mainly because the footprint of those systems exceeds 8 GPUs. So you want a high-speed interconnect.
Absolutely.
Across 16 or more GPUs.
The only thing I'd add there, Jim, is that one of the really cool features we've had in our GPUs since the Ampere generation is what's called MIG, or multi-instance GPU. And it's something that you as a customer can actually enable. So if you can actually take that GPU and turn it into 7 accelerators if you want to, and then run an individual neural network on each one of those. So you can really kind of light up the whole GPU doing inference. So that's, again, it's very application specific as to whether or not that's a fit for your particular needs, but that's another interesting way to use H100 GPUs. Okay, oops, I just closed the chat window. Are there any other questions here? I think I saw there was one other one about RAG models. I'm not familiar with that acronym, I have to confess. About OpenAI, is that something, Matt, you could speak to?
I'm not familiar with RAG models. I would say if you're using OpenAI as a service, you don't really have to worry about the VM that's running in the background.
Okay.
Right. It's basically the same function as any other API-based service.
Okay. Just one last scan here because we're just about at time. I believe we've answered most of the questions. So I think with that, we're just about at time. I'd like to thank you for attending the session. Please do provide feedback. That helps us better tune these sessions for you. We'll look forward to meeting you all again soon at a future Build conference. Enjoy the rest of the conference and happy developing. Thank you, everyone.